that for all integers a, b and c, if c doesn't divide ab, then c doesn't divide a and c doesn't divide b. So that sign, that symbol, it's an interesting one. If the little cross across it wasn't there, so say it was something like this, c and like that, that's saying c divides ab, as in c is a factor of ab. If you divide ab by c, you will get an integer result. So then if I just put a little cross through it, it means the opposite's true, doesn't. So that's the terminology. So we are looking to do a proof by contrapositive. And it's actually quite awkward to write the contrapositive. Proof by contrapositive, so we need to find the contrapositive. Remember, if we had P implies Q, then the contrapositive of that is negation of Q implies negation of P. So we have, and we've got an if and a then, so the actual statement or a proposition is so if C doesn't divide AB, so C doesn't divide AB implies, remember this is if then, implies that C doesn't divide A and C doesn't divide B. Right, so now we need to write the contrapositive, which is quite hard. Contrapositive of that statement is, well, we know we need to flip them around. We're looking to negate both. So this is quite easy to negate. That's just going to be C divides AB. See, the negation of C doesn't divide AB is C divides AB. The negation of C divides A, or doesn't divide A, sorry, is going to be C divides A. The negation of C doesn't divide B will be C divides B. The difficult bit is the and. Now there's a thing called De Morgan's law. Says that the negation of this and becomes an or. So this will become or is negation. And I'll write that down. This is De Morgan's law. And you can always use it. So yes, you have to negate the things either side of the and as well. But the actual and itself, the negation of that is an or. So it will be a very useful thing to remember. So now our contrapositive statement, remember we need to flip these around, so it's going to be if C divides A, remember the and becomes an or C divides B. So if this is true, then we need the negation of that, so C divides AB. So this is our contrapositive, right? So now we're looking to prove it, and we're going to do it directly, and what we do, we assume that the left-hand side is true, and then we show that with this being the case, this has to be true. So let's say, suppose that, we'll do it one, because it's or, we can consider both cases. So case one, suppose C divides A. So that means if C divides A, then that means A equals some constant times C. Now you could use a K, but as soon as we're going to use this again, I wouldn't know what to use after K. So when you've kind of got to use two things with different letters, maybe a P and a Q, or an M and an N, something like that, we'll use an M and an N. So that means A equals M times C, so some number times C, where M is an integer. That's just the definition of dividing something, so it means it's an integer multiple of this thing. If we get an expression for AB, well, we just need to multiply both sides by B. So that would be AB equals MBC. Okay, so that is showing us, remember we're looking to show that C divides AB. B is a we can see here that this is an integer because we've said M is an integer, and we also know that B is an integer. So that is showing us that C divides AB. If we do the same for case 2, we're going to suppose that C divides B. So that means that B equals something times C. So B equals some integer, which we've used M, so we'll use N. B equals N times C, where N must be some integer. Okay, again, get this expression for AB, which means that we need to multiply both sides by A. So AB will equal NAC. Right, so if you look, we're looking to show that C divides AB, so you can see that AB can be written as an integer times C. So that shows us that C divides AB. So either way, in either of these cases, case 1 or case 2, it is shown that C divides AB. So if either of these things are true, then this is definitely true. So we have proven the contrapositive, hence contrapositive is true. So our original statement is also true.